Build incrementally with fast, integrated learning cycles. Well, this is kind of a compound thought too. But I mentioned earlier how doing this for 40 or so years teaches you some things. Not everything new is better, and not everything old is stupid. And an example of something that isn't stupid was, this is largely credited to Deming. If you read his work, he credits to Shewhart in the 30s that said, look, we need a pragmatic and systematic way to approach the development of new knowledge. And that way is going to be, think about the basic scientific experiment. We need to have a plan of some kind. We execute the plan. We check what we're doing and we adjust. And that's called PDCA. This is a fundamental construct of scientific discovery, of knowledge creation, and it's a fundamental recognition in lean. So an iteration is not a shocking new thing, right? What is a sprint? It's a plan, do, check, and act, right? Plan the sprint, execute the sprint, do the demo, make adjustments, and plan the next sprint. So sprinting is no more than a series of PDCA cycles. And why do we do this? Because we need knowledge, right? We don't have knowledge. We have a guess, we have a plan, we have a hypothesis. This is the iterative learning cycle. If we leave that, we're going to leave Agile and Lean and we're going to walk into an area I don't want to be. We need fast feedback. We need to learn via actual implementation and discovery. The shorter this is, of course, it improves the much shorter time between action and effect. So if this was I'll just pick on a 3-week sprint. That's not a terrible thing. When do I get my feedback? 3 weeks. So, well, that's pretty fast compared to 12. Is it as fast as 1? Well, no. So a 1-week sprint gets faster feedback. Well, what's the economic trade-off? Well, that's a good discussion. We'll have that discussion down the road a piece. But in any case, faster is faster feedback, and I learn more quickly. So the people that are there are still there. They did this. They're the ones that wrote the code. Reduces the cost of risk-taking by truncating unsuccessful paths quickly. Not every path can be successful. If you want to pride yourself on innovation, you better be proud of some mistakes, because you can't innovate with a perfect track record. It's just the opposite. You try, you adjust, you try, you adjust. You hopefully don't run all the way back to here, but you end up at a place that was not the place. We were aimed for here, we made a mid-course correction, we stayed on the correction, we're okay there. But guess what? If I have a fast PDCA cycle, I can decide right away. I can reduce the cost of risk-taking because I only ran 1 sprint. Or it's a really big system, 1 PI. Okay, fine. Okay, depending on the size and scope, is that valuable? If I learned that this course of action is a poor course of action, is that valuable? Yes. Okay, what about all those dollars? Well, they're spent. You already lost them at the crap machine called the innovation crap machine. We lost those dollars. Let's not worry about that. Let's only worry about, we've now learned all the dollars here. Who cares? They got us to a point where we learned something useful. There's sunk cost. Let's go that way. Facilitated by small batch sizes. Well, how is it facilitated by small batch sizes? It's very simple. I can get feedback if I have a small batch a lot quicker. Requires increased investment in development environment. Why? Because if we're not set up to do this cycle very quickly and to get to the point where I can actually check, I'll just pick for the sake of argument right now on test automation. There is no test automation. So how fast is my PDA cycle? Well, this check process goes on forever. It seems to take forever, and then I get to adjust, okay? Well, what if my test cycle was this short? Well, now I get to adjust much more quickly. Well, I might need to invest in test automation, continuous integration environment, different building environments, different ways to integrate, optimize integration paths, not integrating everything, integrate the stuff that's important. So I may have to make some investments in development. So if you're a manager viewing this course, and your teams are saying, we need better test automation, now you know why, right? Because they're accelerating the knowledge. You probably knew that anyway, but just to kind of make the point that that's what we're striving for, is better environments to get that faster feedback. And the shorter the cycles, the faster the learning, period, end of story. Why do we like short sprints? Why do we like short cycles? To get fast feedback. Why do we like shorter ones even better than longer ones? Because the shorter the cycles, the faster learning. All we're doing is learning together about this new system. It's innovation, right? This new system does not exist. We have no knowledge about it. We have an insight that it could exist, but it doesn't. We have to build it. The shorter the cycles, the faster the learning. Let's apply those fast learning cycles. And I'm going to walk to the board here in a second and tell you a little bit about the Harley-Davidson story and one of the coolest things they learned about building Harley-Davidsons. And one of the things I like about the Harley story is that it uses different language to describe Agile and Lean. And, you know, I don't even know, frankly, at the time if there's software in a Harley. I assume there's at least some microcontrollers in some places, but it's about building big systems. And they learn the same thing that we learned, and it's so well written. I strongly recommend the book. It's also fun. I mean, what's more fun than reading about, you know, the rebirth of American icon? You remember the days in the 80s where the Harleys they certainly were no Honda Goldwing Coupe. They were really pretty, even though they didn't start. And they evolved then to recapture the fancy of the American public, and they did that through basically Lean. And what are their key takeaways? Integration points control product development. Wow. I want to control the uncontrollable. I need integration points to do that. They accelerate learning. I get my feedback much quicker. I can proceed no faster than the slowest learning loop. So this is an important discussion about the fact that maybe this is, you know, maybe I'm sprinting here working on the drive belt, but until the drive belt is hooked up to the motor, I don't really understand whether or not the drive belt can handle the torque of the new motor. So this pace determines the rate of innovation in that subsystem. Well, if I can only pull the whole Harley together less frequently, then that's right, then that controls the slowest learning loop. So refer you to the Lean Machine, and I'm going to tell you a story here in just a quick second to show you one of the key learnings there. It's a fascinating piece that ties right in. Improvement comes through synchronization of design loops and faster learning cycles, just like we see in SAFe. Faster learning cycles, shorter iterations, 2-week sprints, typically sometimes 3, sometimes 1, PIs that are maybe 8 or 10 weeks at kind of the system or solution or business level. Our improvement comes when we make our design loops faster and faster. Now let's take a look at a great vignette from Harley-Davidson. So the Lean Machine, the Harley-Davidson story by Donter Osterwald is one of my current favorite books. I read pretty much continuously. Hopefully, like you, we have a book open all the time, either on my Kindle or one in my backpack on the way to wherever I happen to be traveling to. And the Lean Machine is one of my favorites for a number of reasons. Number one, it is technically competent and yet really a fun read. I mean, who doesn't want to read about the recovery of one of America's greatest institutions, the Harley-Davidson Company? If you've ridden on a Harley, well, it's quite an experience. I don't know if I could recommend it necessarily, but I certainly have. And some days I'm tempted to get one, but I guess I'm kind of beyond that now. But anyway, it's a great book. And in that book, there's a series of vignettes that taught me Agile, or taught me how to think about Agile from a manufacturing perspective, from an inside-out perspective. And I want to share that here. Now, it's not a particular figure in the book. It's not a paragraph. It's not even a chapter. It's a story about how they learned about the value of Agile and Lean development. And the story goes as follows. They were struggling, of course, shipping high-quality Harleys, and many times they didn't ship well. They didn't have good quality. That was one of the reasons that they were looking at the lean process. So let me just draw a curve here of time and value, and talk about projects. Really great projects have some form of a plan, right? Programs, whatever you want to call it. Building the 2016 model Harley-Davidson. The build out of various Harley-Davidson models that go well would track a curve a lot like this. There's a point in time at which they would like to be able to ship that new Harley. Maybe we'll just say maybe it's January of 2017. There's a time in which that Harley is complete. So this is completeness. This is kind of the percentage complete, if you will, or earned value from that world. This is a percent here, okay? So this is value over time. Good projects track along that curve, and you know, you can kind of depend on that. We delivered a cool Harley about the time that we said they were gonna. But as you know, or we're going to be telling the story, they weren't delivering projects on time all the time, and they started to do some analysis to try to figure out why that was. And as you saw in that slide before, the first thing they looked at was their product development life cycle, and they said that do teams that deliver reliably in accordance with the phase gate milestones, teams that exit, design complete well, do they do better? Are they these types of teams? And versus let's say a program that doesn't go as well, right? It ships late. It ships sometime later, and clearly you're not really on the curve anymore, the plan curve. And what they discovered, and that's what the bullet says, is that there was no correlation. So if you exited the phase gates exactly on time per the plan, let's just say that phase gate for design complete is right here, there was no further correlation. Exiting the phase gate on time did not mean that you were on this line. You could just as easily be on this curve. And while the data is perhaps not conclusive, they suggest in there, and that's what the bullet said, is that it appeared that the inverse might be true. Okay, so we talk about that a little bit in terms of the nature of those milestones and how they're not particularly helpful. The inverse may well be true. Well, we can speculate why that is. Pick too early in the cone of uncertainty, but we're not really sure. So then they were stumped. If our product development life cycle isn't helping us deliver on time, what is? So someone in the group, somebody in the lean working group, had an idea to start tracking purchase orders. So they started looking at purchase orders over time, project A versus project B. So this is Harley A and this is Harley B. And they looked at the programs that are delivered on time, and they looked at the pattern of buying over time, and they found the following. They found purchase orders frequent over time. Lots and lots of little purchase orders. I have to order a new tire. I have to order a new drive belt. I have to do a little refit on that carburetor, see if I can get a little more horsepower out of this engine. Lots and lots of small purchase orders throughout the system. Okay, and then they looked at this other class of projects, the one that tended to follow these curves. So there are lots of projects involved. So I can't exactly indicate that, and they're all over heck here. And some of these, of course, were not exactly perfect, but these are a series of lines, right? A series of lines, a series of programs. So they had pretty decent statistical data. So then they looked at these and they said, let's look at the purchase orders over time for building a Harley on the programs that didn't seem to perform quite as well. And the plot looked a little bit different. Pretty similar up to a point, and then what's happening? Well, you have to read between the lines and make some assumptions, and we'll do that here. It looks like what's happening is that these folks were in the zone of false positives. We've designed that Harley. We feel really good about it. We've got sign off on the documents. We went to the machine shop. We checked with manufacturing. We checked with our suppliers. We're largely good to go. Okay, so we feel good about it, and then we'll proceed until we get later and later, and then it turns out that it didn't quite work, and we had to order a bunch more parts. So I think you can see what's probably happening here. What's probably happening here is this is the zone of false positive feasibility. This is the zone of, well, I'm not really sure. I'm going to continue to iterate and iterate and iterate. Now they had a real problem. So what do? You can't go to your development teams and manufacturing groups and say, let's buy more stuff. I mean, how do you do that? That wouldn't be a good, that wouldn't be taking an economic view. So they said, let's try something different, right? We'd like the programs on this curve to look more like this. So how could we do that? And they said, we need to demo this stuff. Well, the Harley's not done, so initially you can imagine how they felt about that is, please demo Harley Davidson you haven't built yet. Okay, well, please demo whatever parts you can build. Maybe you could get the drive system and the motor on a workbench, on a load platform or something like that. Let's have demos. So they started having demos. Now, there's a lot they don't say in there, but they said when we have a demo, they called it a pull event. These are lean thinkers, and they said we need a pull event. Why? Because they were trying to pull these projects to look more like that, right? Kind of get them back on the good path, the path that's more reliable and more predictable. Well, they don't say in the book, by the way, if they did that routinely, but let's just say for the sake of argument, let's pretend that they did. And they had a pull event here, and they have a pull event here. Of course, if they're doing these pull events, what's happening to this line? It's not looking like that anymore. It's looking like this, right? And then like this and like this. So it's tracking better to a more predictable result. They don't say in the book about the frequency, the nature and frequency of those pull events, but let's think in our terms for a second. What's an iteration? What did cadence and synchronization bring us? They bring us the ability to make routine things which can be routine. A demo can be routine. What if this is simply period of time, and every period of time we have a system demo? Now you have a cadence-based pull event to help the projects that probably weren't tracking to where they needed to be come back to the line of goodness. I think that's a really cool insight, and I think that that's the thing that you can only get by really reading, understanding the work, and seeing how they learned about cadence and synchronization, how they learned about the value of demos, even when the notion of a demo, obviously I don't have a full Harley Davidson, so I demoed various pieces of the Harley Davidson rather than full Harley Davidson, how the notion of a demo, how the notion of, in our case, how the notion of a cadence-based demo can help this curve look a lot more like this one, and you'll come out with better programs too. So what you saw in that vignette is how integration points reduce risk. And this is a clean call out, not in this picture necessarily, but these words came from the Lean machine, false positive feasibility. What's that mean? It means that when I was running the waterfall model, building a Harley or a CRM system or a SaaS system or a point product that runs on somebody's desktop, I believed I could make a system work, okay? And I can in the end. But I discover that without these integration points, I have a problem over here. It doesn't work. I have my little explosion. Boom, 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 boom. Everybody's unhappy. It's late, defect ridden. And by the way, there's a problem with the design. So I have to go all the way back to earlier steps to solve it. Why? Because I didn't get any fast feedback on the fact that that design wouldn't work. This is a zone of false positive feasibility, okay? This is where a lot of us live. So if we've been in a world that says we thought we were going to ship it and we didn't, that means we were in this zone of false positive feasibility. We lived in here. We want to get out of that zone. How do we do that? We do that with integration points, just like the example that I just showed you on the board. Those integration points control product development. The faster you do them, the faster you get deadline. And that's the way we reduce risk. So I'm often in discussions about, things like bimodal IT and the nature of big systems that are hard to adjust. And I ask a slightly different question, not whether, Agile applies or not, although I think you understand my view of that, but whether or not we can approach this in a way that absolutely reduces risk. And any method that we use that gets fast feedback and reduces risk has to be a good method because it's going to create better economics.